Your FastMCP server works perfectly in isolation. But what happens when you need to run it with a specific Python version or inside a project's virtual environment? We'll see exactly how to configure Gemini CLI to launch your server with precise Python version control or within an existing project directory, ensuring your dependencies and runtime match exactly what your code expects. Hash with specific Python version. Gemini MCP add ML server UV, run Python 3.11 with FastMCP run server. Hi. Hash within a project directory. Gemini MCP add project server UV, run project path to project with FastMCP run server. Hi. This demonstrates the command composition pattern for integrating local development tools with external systems. The examples show how to chain specialized CLI commands to create a reproducible execution environment, where each command handles a distinct concern: dependency management, runtime configuration, and process execution. The distinctive aspect is the separation of environment setup from actual server execution, enabling clean, modular control over complex workflows. The pattern works by layering abstractions through command line composition. The outer command, Gemini MCP add, registers the server with the target system, while nested commands, UV run with FastMCP, handle the execution environment and dependencies. This creates a declarative pipeline where each component focuses on its core responsibility: dependency resolution, Python environment management, or server execution, without tight coupling between layers. This approach matters because it solves the problem of environment drift and configuration complexity in local development. By externalizing setup logic into composable CLI commands, you eliminate manual virtualand management and dependency conflicts. It's particularly valuable for AI tooling integrations, where you need to expose local Python functions as remote-capable services without modifying the original codebase or dealing with deployment boilerplate. The trade-off is initial CLI complexity, but the payoff is consistent, reproducible environments across different machines and projects. Let's break it down line by line. Hash with specific Python version. Gemini MCP add ML server UV, run Python 3.11 with FastMCP run server. Hi. This command registers a new FastMCP service named ML server using Uvicorn as the ASGI server, explicitly pinned to Python 3.11. The with FastMCP flag injects FastMCP's optimized middleware stack, while FastMCP run server Pi specifies the entry point. Critical for production deployments where Python version consistency prevents runtime conflicts. Hash within a project directory. Gemini MCP add project server UV, run project path to project with FastMCP run server. Hi. This registers a project-specific MCP server using the FastMCP runtime. The project flag scopes the server to a directory, ensuring all tool definitions and dependencies are isolated to that project. The pattern mirrors the Python version example, but binds execution to a project context instead of a Python interpreter version. FastMCP deployment patterns. The Gemini CLI integration with Gemini MCP add commands demonstrates FastMCP's environment isolation philosophy, where servers run in completely controlled contexts with explicit Python versions, project directories, and dependency management. Specifying Python or project switches execution from your local environment to an isolated UV-managed context, which can cause silent failures if dependencies aren't properly declared. The real power comes from treating your server's environment as code, versioned, reproducible, and completely self-contained.
The server that forgets its environment. remembers every dependency